Hi, good afternoon. It's Jim from the mavestar Observatory. Just before we move on to some more interesting points, guys, what is your opinion with Greta Thunberg, this little Swedish girl that's came out now to the world stage on climate, arguing that CO2 is the cause of global warming, and as a result she's left school, I believe, and she is now taking the world stage to combat more CO2 going into the atmosphere, and as she believes, cut global warming and carbon emissions into the atmosphere. My opinion is that what we're seeing right now is direct action, and you're probably going to find at the bottom of my video, if you're on a PC or desktop, I'm not sure, in fact they do come up on the mobile phone devices as well, this banner from Wikipedia on global warming, and you'll notice that this is being shown on anybody that talks on the subject of climate. It seems that they do not want alternative views with regards to what is driving the climate on the earth right now for some reason. But I'll be interested in your views on what you think about this. Is Greta a puppet for the elitists and their agenda? Is she really not understanding what is causing the climate, and is she genuinely concerned that it could spell disaster for the future and her generation and generations to come? So I'd be interested in your views on that. So before we get into it, guys, as always, a huge thanks to the few that are supporting us on Patreon and those that make a one-off payment on PayPal. Guys, that there's probably very few people on YouTube and on the internet that actually do more than just talk and show data. And I've got to give them credit. Some of these people do their work, and they go back into the historical records to find data on climate events, such as the warmest day of the year compared to previous warmest days in the history, sea ice extent over the Arctic region, and lots of other topics that are related, and sometimes we talk about. But we are one of the few channels that actually do a little bit more, and we try and answer the questions. So with those people supporting us like they do, we're able to do what we do, and that is actually build the equipment to ask the questions. Some of the questions that we've answered already is the magnetic poles migrating on this earth still? And they are. We know they are, simply because we've got equipment that monitors the position of the magnetic North Pole every 3 seconds, and we've been collecting data for the last 2 years. We know it's migrating month on month. We know it's slowly progressing towards Siberia, and we know that when Earth goes through a magnetic reversal, that the magnetosphere weakens. And we can ask that question today: as the Earth's magnetosphere weakened? Well, what we can say as an answer is not by anything over the last 2 years that we've noticed with the equipment that we've built specifically to monitor the magnetosphere. But that doesn't mean it will be that way in the future, because as we believe on this channel, and my theory is, when it gets to a total movement of migration of 40 degrees across the northern hemisphere, it will start to enter the weak field lines. And from some of the experiments that I've conducted and you've seen on this channel, when things go into the weak field lines, things start to get very fast in migratory processes, and the north generally will move over to the safe position, and when it does that, we will have a magnetic reversal. So the magnetosphere at that point in time should weaken considerably. How long it will take to do that is still to be answered. We know that from looking at the magnetic high intensity over Canada right now and its dissipation over the last 7 years, it stands to reason that there's probably 4 to 7 years before that completely dissipates, and that will send that magnetic pole further and much faster over towards Siberia, and that could be the point at when we get our Earth's magnetic reversal. Now, in comparison to anything else, I think that when you compare the Earth's magnetic reversal with the grand solar minimum, which is the worst, if you ask me, it's our primary defence. It's the magnetic reversal that we should be concerned about. Yes, we should be concerned about the grand solar minimum, because that also aids to the same problem as what the weakened magnetic field would be during a magnetic reversal, but they don't generally last as long as magnetic reversals do. So my point is this: our primary protective shield during a magnetic reversal goes down, and in turn more cosmic radiation comes inbound. Whilst we have a magnetic reversal slowly taking place on this planet, and although we haven't seen much of a shift in the last 2 years of the magnetosphere strength, we do know from other organisations out there that they have it has dropped to around 15 to maybe 25% in its total strength, and that is 1/4 of our total protection on Earth. We know that when more cosmic rays are inbound, we get more gamma rays, more muons, more pions forming, and they are a form of radiation that are not even on the considered list of types of radiation that are harmful to human beings. And I think this is something that needs to change in the future, because as we will see a little bit later on, when we start to have collisions in the upper atmosphere, it triggers showers that rain down on the surface of the Earth. And as you can see on this diagram, you've got gamma and proton, which are hadronic showers. In the hadronic showers is where the muons are formed, and the difference between the two types of showers that we get down raining on the surface of the Earth is one spreads out a lot more than the other, and the one that spreads out a lot more than the other is the one which contains the ionized muons. And you know, like I say, they've not even classified it on the list of harmful radiations, yet we know that as you go down the wavelength, the radiation source gets more potent. So you must be wondering what we can do to protect ourselves during the times that we're in, with regards to, you know, there being a weakened magnetic field letting more cosmic radiation in, and a grand solar minimum which lets more cosmic radiation in. And the cosmic rays don't just create radiation, they actually create platforms in our clouds for cloud nuclei to condense on, and therefore build up cloud mass in our upper atmosphere, and that in turn can block out sunlight, and in turn can lead to a cooling of the planet. And we can see that over the last 10 years or so, there has been a steady but constant cooling of the Earth's temperature over that period of time. Now, like I say, the three most common, and I think there is a fourth one that they've not put in here, which is X-rays, but it doesn't matter, but the three most common types of radiation can be shielded, but it just depends on what type of radiation it is, how long the radiation you're exposed to, and of course the quantity of radiation that you're exposed to is what tells you how dangerous it can be. So you don't want to be in a vicinity where there's a lot of radiation for even a short period of time, or you don't want to be in a vicinity where there's a moderate amount of radiation for a long period of time, because time and amounts obviously amount up to harmfulness. So it takes a little bit of you know, getting your head around it, but you can shield these three types of radiation, and you can also shield muon types of radiation as well, even though, you know, the muon is further down the wavelength from gamma. So, you know, in terms of radiation and which is worse, muon radiation would be more worse because it's on a shorter wavelength. So the thing is, if you're exposed to a lot of muons at a short space of time, then it becomes harmful. If you're exposed to a moderate amount of muons over a long period of time, then it becomes harmful. The real thing here, guys, is you don't want to be exposed to any forms of radiation for any amount of time. But we do live in an environment here on this surface of the Earth where, you know, the background radiation is less than 1 millisievert per hour, and that is, you know, acceptable on the international scale of radiation and what is allowed for public consumption, if you get what I mean. I know it's not the best way to put it, but there you go. So if you want to shield alpha particles, 1.5 inch or 1.2 inches of air will do it. About, you know, 0.008 inches of water will block it, or a piece of paper or even skin will block it. But if it does penetrate the skin, it's still harmful. Beta radiation can be blocked by a couple of inches of water, or a thin layer of glass or metal, or additional covering, for example heavy clothing, and of course a small amount of metal will block beta radiation. But when you get to gamma radiation, as you can see, you need about 13.8 feet of water, or around 6.5 feet of concrete, or around about 1.3 foot thickness of lead will block it. So if we're talking about gamma radiation, you could add a little bit onto those figures for gamma, and you'd probably be not far off where you'd need to be to block a lot of gamma radiation. Are we going to need to block that amount of gamma radiation in the future? Well, the only way we can answer that question is by taking background readings like what we're doing right now, and we can also target certain regions of our Earth, such as Brazil or South Africa, with our muon detectors and also Geiger counters, so that we can get a background reading of standard radiation, and then we can get a reading of the muons in those vicinities, and then we can compare it with regions that have high intensity protection, like South Australia right now, and then we can go for a moderate region on this Earth, and we can bring back that data and analyse it. And that's what we're trying to do. Hopefully before the new year, we hopefully will have a magnetometer either in Brazil or South Africa, along with a Geiger counter and along with a muon detector, and we'll be able to get that data back here, analyse it and answer those questions for you. Because if the Earth's magnetosphere is going to weaken, and it does during a magnetic reversal of the Earth, then we are going to have more cosmic ray impacts with air molecules in our atmosphere, and as a result of what you just saw, we will get more of these muon showers and proton showers taking place, and in that case the radiation levels will go up. So that's what we're doing here, guys, and we're efforting the answers for you right now. That's why we're building the equipment, and that's why we've built a lot of equipment this year. It took a couple of years to get the first piece of our equipment up and running, the TriMag, but I didn't give up and I delivered it. We then earlier this year set out to put some magnetometers in different locations in and around the world. We did it, we got them out there, and if you go onto the website, you can see that when that data comes in, it is updated regularly on the global magnetomic data page. I've got some to process that we've had recently from the Gold Coast in Australia from Richard. That should be going up there either later on today or tomorrow. And we've built also now these muon detectors to go around the world to answer the question how much muon and how dangerous they are, and that's what we're working on right now to answer for you guys. But guys, we can only do as much as we get supported to do. And I just want to mention just briefly that there's a link down there on PayPal you can help us out with, or on Patreon. And if we get a little bit of support, then we can do a little bit of work here, and we can answer those questions for you during this rare time. And it is a rare time, you've got to remember that, guys. The last time the Earth went through a magnetic reversal was 780,000 years ago, and that's why it's worth giving a small observatory a little bit of funding, so that we can do a little bit of work and answer some questions for you, because there is a big concerted effort right now to stop the individual getting knowledge of what really is causing climate change on this planet and what to expect for the future. Well, a small observatory and a scientist like myself can help answer those questions for you, but I must have lead in the pencil, or I must take the horse to the water. In other words, guys, I must get at least a little bit of funding to do it. There's no other way. So I'm here, guys. If you want to support me, the links are there, and I'll say what I do as always. Bye for now. Have a great day.